students, welcome to our learning channel of mathematics. As we discussed in the previous video about random experiment under the playlist probability. Now, one more terminology before going to that. Here in this video, I would like to cover how to calculate number of outcomes when a random experiment is conducted. Already I gave 4 examples or 4 experiments you can say. We shall see the formula is to calculate the number of outcomes. Second one, I am maintaining serial number 1, 2, 3 like that so that you can have that continuity. In tossing a coin, always you must write in tossing a fair coin, fair or unbiased. The meaning I already explained to you in the previous video. In tossing a fair or unbiased coin. When a coin is tossed, what are the possible outcomes? So the formula is 2 power n. 2 power n gives number of outcomes. Number of outcomes. Here n stands for this small n. Power of 2 stands for number of times one coin tossed. For example, you take a 1 rupee coin, if you flip or toss 20 times, n becomes 20. N becomes 20. Or in some cases, number of coins. Whether you are picking up 2 coins, 3 coins or 4 coins, the n will hold same number. So it depends on situation. This may be used or this may be used. N can be in 2 ways you can use. Number of times one coin tossed, or number of coins tossed. Depends on situation. This formula to be used. This gives number of outcomes. Number of outcomes. Why we have taken 2? This is base 2. Base 2 is taken because every coin will have 2 possible outcomes. One is head, other one is tail. So 2 possibilities of outcomes. One is head, other one is tail. That's why base represents what are the possible number of outcomes on a coin, head or tail. That's why 2 is a base, and super the exponent n gives 2 ways of representation. Number of times one coin tossed or number of coins tossed. Number of coins tossed. You should be very careful the usage of the formula. Same formula in different context we are going to use. Now we shall see how it is going to help you to set the outcomes. If you take n is equal to 1, what is the meaning of it? Tossing one coin, or a coin is tossed one time. See the context. So if n is equal to 1, then number of outcomes. Outcomes means what is the result you are going to get on performing that experiment. Outcomes is given by the formula 2 power n, that is equal to 2 power 1, that is equal to 2. This 2 is nothing but you may get head, you may get tail. Or the same way, if I take n is equal to 2, if n equal to 2, then what is the meaning here? When 2 coins are tossed or a coin is tossed 2 times. Initially I wrote 2 different contexts of n. If n equal to 2, then number of outcomes is equal to same formula 2 power n, that is equal to 2 power 2, that is equal to 2 into 2, that is equal to 4. 4 possible. Here I wrote head and tail. How you are going to show that 4 outcomes? Here I am going to give you a tabular chart to write down those outcomes very simply to understand. You take a table, half of 4 is 2. So write down one head, one tail, one head, one tail, total 4. You take one outcome alternatively. You can start with the tail first or head next. It is immaterial. Head, tail, head, tail. Total 4 are there. In this 50%, 2 of them will be heads, 2 of them will be tails. Next, you double it. Alternatively, 2 heads, 2 tails. So these are the possible outcomes when you toss 2 coins or one coin is tossed 2 times. So when you suppose for example you took 2 coins, you tossed, and we are going to observe the outcomes what they are going to land on. Head you may get first coin tail, second coin head, first coin head, second coin tail, tail, tail. These are the possible outcomes. Outcomes, possible outcomes. To extending the same idea for n equal to 3. For n equal to 3, so maximum n equal to 3 case is possible in coin problem. Suppose if I take n equal to 3, you can guess if I take n equal to 3 means tossing 3 coins at a time, or one coin tossing 3 times. Different version. So then number of outcomes is equal to same formula 2 power n 2 power 3, that is 2 into 2 into 2, that is 8 possibilities, 8 outcomes. How you are going to show these 8 outcomes? Same manner in a tabular chart, how I explained just before. So first, alternatively, you write out head and tail or tail or head, so that each column contains 8 outcomes. So head, tail, head, tail, 1, 2, 3, 4. Again, head, tail, head, tail. 1, 2, 3, 4, 5, 6, 7, 8. Now you double it. 2 heads, 2 tails. 2 heads, 2 tails. Now again double this column. 4 heads, alternatively, 4 tails. You got the outcome chart. Outcomes. Possible outcomes. So you are going to get 3 heads, coin 1, coin 2, coin 3, or same coin if you flip 3 times or toss 3 times, first time head, second time head, third time head, like that. Next, tail, head, 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 tail, head, tail, tail, head, 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 tail, tail, head, tail, head, tail, 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 tail. These are only 8 possible outcomes you are going to get. So, it depends on again 2 power 4. If 4 coins are taken, 2 power 4, 16. So it goes on like that. It is general formula to denote or to find number of outcomes in case of a fair coin. Fair coin. Let us continue further. Yes, let us continue. Third one, rolling a fair die or dice. Just like the method I explained for a fair coin or coins, here same idea we are going to apply to find the total number of outcomes what you are going to get when a die is rolled one time, two times, three times, four times, etc. Or two dice are rolled, three dice are rolled, four dice are rolled, same contest. So here the formula is 6 power n. 6 power n gives the number of outcomes. Here also same thing. N represents small n. What I wrote here represents number of dice. Dice plural form of die rolled, or one die rolled n times. Both are same. It depends on the situation which one you need to consider. If only one die is there, how many times you are going to roll? Then n becomes that number. If you roll two times, n is 2. If you roll three times, n is 3. Other sense, I take two dice rolling one time.
Here n is equal to 2 days. If n is equal to 3, 3 days are rolled. So it depends on situation, the problems, we are going to use the same formula. Here base is 6. Base is 6. In the previous example or the experiment, I took 2 is the base because for a coin, 2 possible outcomes will be there, head or tail. For a die, there will be 6 possibilities in numbers 1, 2, 3, 4, 5, 6. So die contains these numbers, that's why base is 6. So mostly in problems, logical problems, n will be 1. N will be 1. Then number of outcomes in this case will be equal to 6 power 1, that is 6. So you may get here the outcomes can be 1 or 2 or 3 or 4 or 5 or 6. Any one of these numbers going to get 6 possibilities are there. If n equal to 2, then number of outcomes will be equal to 6 square, that is 6 into 6, that is equal to 36. It is a big number. 36, this we are going to show in a table form. That will be continued soon. So here, continuing the same thing, if you roll 2 dice or two same die 2 times, if you roll like that, then the number of outcomes is equal to 6 power n, that is equal to 6 power 2, 6 into 6, 36 outcomes are there. How you are going to show the outcomes? Here what you will do, generally by default we take two different dice of different colors. You take a table. Here I will take one blue die, red die, red die 1. First die, red color, it has outcomes 1, 2, 3, 4, 5, 6. If I take one more die in blue color, die 2. Here I will show the outcomes of that die 1, 2, 3, 4, 5, 6. Now the outcomes we can show 1, 1. when you roll a die or two dice are rolled, on red die, one appears, blue also, one appears. The meaning of this one, 1, comma 1, 1. Next, this side, 1, comma 2. This side, 1, comma 3. It is 1, comma 4, 1, comma 5, 1, comma 6. Next, 6, 6. You see, 6 into 6, 36 outcomes will be there when you roll two dice are rolled at a time. These are the numbers that are going to appear. Red, actually, if I use red, I should use red for first coordinates, blue for second coordinates. Clearly, it is mentioned here die 1, die 2. The first numbers of each ordered pair in the bracket, what I show you, are the outcomes of first die, and second numbers are the outcomes of blue die. So 36 possibilities or outcomes you are going to get in the case of rolling a die. 6 4 is the formula. And the last one, the fourth one in this video, deck of cards. Deck of cards. I already gave the description to you in the very first video under random experiments of deck of cards. If I say,
So this is the next one, deck of cards. Here we can pick one card, two cards, or three cards from deck of cards. Already I gave you the information about deck of cards in the previous video under random experiment. So here the formula how to calculate. Generally we take only one set of deck of cards. They won't give you two deck of set of cards. So in problems, in coming problems on probability, when problems are based on deck of cards, they will consider only one set of deck of cards. So your base will be 52. Power is n. This is gives number of outcomes. N stands for how many decks you are taking. Number of decks. Number of decks. And 2 is a base. Because deck contains 52 cards. 52 cards. This is about the formulae to find out number of outcomes under the random experiments, whatever you consider. In next video, we will discuss about one more terminology called events. What is the meaning of probability? How you are going to define probability in different aspects so that the concept will be ready for you to tackle problems practically. I hope this information is effective for all the students so that they can able to tackle problems on their own by understanding the concepts very clearly. Do like, share, and subscribe our noble channel so that every student will get benefit out of this. Stay blessed, all of you. Keep learning always. Thank you.